Hello students, in this video we shall discuss the chapter 8, that is motion, of class 9 science. Now in this session we shall discuss the graphical representation. Now in graphical representation of motion there are two types of representation. One is distance time graphs, another is velocity time graphs. So let's start with first distance time graphs. Now already we discussed two types of motion in the previous video, that uniform motion and non-uniform motion. So first we shall see the distance time graphs of uniform motion. So what is uniform motion? It is the distance traveled equal distance of an object travels equal distances in equal interval of time. So if I plot a graph, if just I am simply showing a graph. See, this is the x-axis and this is the y-axis. In x-axis we have taken time, 20 minutes, say 40 minutes and 60 minutes. These are time in minutes. And in this y-axis we have taken the kilometers, 10 kilometer, 20 kilometer, 40 kilometer. These are the distance. Now in first it travels equal distances in equal interval of time in case of uniform. So for in first 20 minutes it travels 10 kilometer. Next 20 second it travels next 10 kilometer. Next 60 second. Next 20 second it will again sorry, it is 30. It travels again 10 kilometer. So 10, 20, 30, these are the equal intervals of distance. So if I plot this graph, it will be simply a straight line like this, which is making an angle with the x-axis. So this will be the representation of the distance time graph of a object in uniform motion, simply a straight line. But if we draw, if we see the case of non-uniform motion, so in non-uniform in similar way, in x-axis we take the time 0 to, this example is also mentioned in your book also. I am taking these intervals of time. These are time in second. And this way I am taking distance in meter, sorry. So first 5, then 10, then 15, 20, 25, 30. Now non-uniform motion, see it an object travels unequal distances in equal interval of time. First in 0 to second, suppose it has traveled one meter. So it is in vertically distance are measuring, so one will be like approximately here. So first point is this. In the next 2 seconds, suppose it has traveled 6 6 meter, then it will be roughly there 5 and 6, it will be approximately this is, I am just plotting the point of in graph. And in the next 2 seconds, suppose it has traveled 12 meter, so 10, 11, 12, approximately there. In the next not 12, suppose say it is 15, and in the next 2 seconds, suppose it has traveled 25 26, suppose 25 and 26. Now see, when I shall join the points, this won't be a straight line. You see, it will be roughly a curve like this. So it is just showing the non-uniform distance time graph in case of non-uniform motion. In the first interval, it has traveled distance of say 1 meter, and then it has traveled 6 meter, and the next 2 second it has traveled 16 or sorry 15 meter, and in the next 2 second it has traveled 26 meter. So these are the unequal distances, and when you plot this will be a curve, simply a curve. So this is the case of distance time graph. Next come to the velocity time graph. Now velocity time graphs, there is also two case motion we shall get. One is uniform and non-uniform motion. So first start with uniform motion. So what would be the diagram for the uniform motion? So actually in velocity time graph there are two types of diagrams will be there. Two cases will be there in uniform motion. In one case the velocity will remain constant, and in another case the velocity will increase uniformly or decrease uniformly. So let's see, when the velocity remains constant. So number one case, when velocity constant, simply write velocity constant. When the velocity is constant, the diagram will be like this. So in this case we shall take in the time in the x-axis and velocity in the y-axis. Suppose I am taking the time 0, 1, 2, 3, 4. These are the time in hour, and in this axis I am taking the velocity. Velocity in kilometer per hour. Alright. Now first case is velocity is constant. Suppose the velocity is 40 km in every instance of time. So what will be the graph? In first hour it is also 40, 0 to 1 hour it is 40 km per hour velocity. In the next hour it is again 40 km per hour, next hour also 40 km per hour. So this way if we join, it will be simply a straight line parallel to the x-axis. Straight line parallel to the x-axis. Alright. Now what will be in velocity time graph, the area produced under the line, or area produced and in the velocity time graph represents the distance. Now how I am showing this, let's consider this time instant for t1 and suppose this time instant for t2. Okay, so there are 2 points we consider, A and B, and let's drop the perpendicular from A and B. Suppose it is C and D. These are the points. Now what, see, this line is parallel to this line, and when we drop the perpendiculars, these two lines will also be parallel to each other, as these two lines are perpendicular to the parallel lines. So this ACDB is a parallelogram. Sorry, not parallelogram, rectangle. It forms a rectangle as the interior angles are 90 degrees. So in rectangle opposite sides are equal. You know this, the properties of rectangle. And area is, what is the formula? It is length into breadth. Alright. Now let's see. I have already in start I showed that the speed equal to speed or velocity equal to distance by time. So if I cross multiply, then distance is represented as s equal to speed into time. All right. Now this if this AC represents the velocity, and AC and VD are equal because both the lines are equal. So it represents the velocity. Suppose V, and this time interval we can represent T2 minus T1 or whatever. So CD, actually this intercept is CD. So in this way, if we have to find the distance of the object in this from this graph, then required distance will be simply AC into CD. AC into CD. AC is the velocity because we are measuring velocity in along the y-axis. So definitely AC will be the velocity, and this is the 40 km already I told, and AC and BD are equal. And these are the time intervals. I have taken two instances, T1 and T2. So this CD will represent the time interval. In this time interval, object has traveled this much. So what distance it has covered? So simply by formula of speed, we can find the distance equal to speed into time. So definitely here speed is this, or velocity is speed or velocity is this. I'm showing here, writing here velocity actually. The velocity into time. So AC into CD. Then in geometrically, AC into CD represents the area of this rectangle. AC into CD represents the area of this rectangle. So this is the area of ACDB. So the area formed under in the velocity time graph represents the distance traveled by the object. So this is in case of constant velocity. Next we see uniformly accelerated. Or uniformly increasing. Sorry, uniformly changing. Uniformly changing, there are two cases. One is increasing or accelerating, and another will be decreasing. So first let us see the increasing. What will be the graph, velocity time graph, when the velocity of an object will be uniformly accelerated? See, let me show the graph. Okay, all right. So I am taking in the along the x-axis the distance time. Let's show this one. Same velocity and time. All right. So in first hour, it the velocity was 10. In the next hour, velocity was 20. In the next hour, velocity is 30, and next hour 40. So it is uniformly increasing with respect to time. So when you join, it will be a straight line. So uniformly, when these will be uniformly accelerated, this will be a straight line. But when we consider two instances, suppose this T1 and T2, these two time intervals, and let us consider the point A and B. So if I drop the perpendiculars, the area will be formed, and this area will represent the distance traveled by the object, as we find the as we got it in case of the previous case. So in this case also same, this area will represent the distance traveled by the object. So this is just like a trapezium. We can find like this also. If we drop the perpendicular here, suppose AB, and this is CD and E. So this is a perpendicular, so this is a right angle triangle and this is a rectangle, so we should find it separately. First find the area of the rectangle and then find the area of the trapezium. Just I'm showing what will be the distance. Area of ABE plus area of ACDE. So area of ABE, it is half into AE into BE plus, and this is AC into CD, because AC is the velocity, AC or D is same, is the velocity, and CD is the time interval. So velocity to time get the distance. So this distance, and this in geometrically it represents the area of this rectangle, and this represents the area of the triangle. So this way you can find. So these are the this is the case of increasing. Next, if I find the decreasing, then graph will be simply like this. Same graph and point I'm drawing. Suppose the velocity in the first instance was in the 0 second was 40, and next hour it becomes 30, and the next hour it is 20, and the next hour it is 10, and next hour 0. So if I join the straight line, it will be like this. So this will also be a straight line this way. These are the case of uniformly changing. And if the non-uniform, what will be the case of the non-uniform motion? This all we discussed in the velocity time graph. All are the case of uniform motion. One is constant. First case was constant velocity, and the next case was the uniformly changing velocity. So uniformly changing velocity, there are two cases. One is the case of increasing, another is the case of decreasing. So in decreasing will also be same. We can find the distance traveled by the object at an instance. Next, non-uniform motion. What will be the graph for the non-uniform motion? So non-uniform motion, it will be like this simply. So in the first hour, suppose it is 0, then it is 10, and then it is 20, again 10, and so in the next hour 10, and in the next hour it is suppose 30, like this. So if I join, it will be like this way the graph will be there. It will just like zigzag. So this is nothing but the case of non-uniform motion.